If you live near the equator, in places like Uganda, you're used to weather that's warm all year. But travel to the far edges of our planet, and you'll find deadly sheets of solid ice where humans can barely survive. It raises a pretty simple question. We all live on the exact same planet, sharing the exact same sun. So why is the temperature so wildly different depending on where you happen to be standing? The answer comes down to latitude. Think of it as your distance from the equator, the line around the Earth's middle. Watch this orange being hit by a flashlight. Because it's round, sunlight hits the center directly. The energy is highly concentrated, making it hot. But at the poles, the light hits at a sharp angle, spreading out and severely diluting the heat. Back on the real Earth, this unequal heating creates giant, distinct belts of weather that wrap all the way around the globe. So our global climate is really a geometry problem. Your exact distance from the equator acts as the ultimate baseline for whether your local environment will be boiling hot, freezing cold, or somewhere in between. This map shows how these belts are stacked. Right in the middle is the equatorial zone. Because it gets that direct, concentrated sunlight, it stays hot and wet all year round. And this constant rain and heat produce an environment packed with massive, lush green rainforests. Move just a bit north or south, and the map shows the savanna zone. Here, the year splits into a clear wet season and a distinct dry season. This regular dry period creates the wide-open grasslands with scattered trees that dominate much of East Africa. Next, we hit the tropical desert zones. These areas are defined by their extreme dryness. It's the lack of water that really shapes this environment. It is a harsh, bone-dry landscape where rain or snow rarely ever falls, leaving the ground largely barren. Finally, the map completes with the temperate zones, which experience 4 distinct seasons, and the extreme polar caps, where the sunlight is so diluted it remains freezing and dry all year. By looking at this map, you can use a location's exact latitude to reliably predict how much rain it will get, what seasons it will have, and what plants can survive there. But there are places that break these rules. Right near the equator in East Africa, in a zone that should be boiling hot, you can find environments covered in freezing snow. This happens because of altitude, or your height above sea level. The mathematical rule here is that for every 1,000 meters you climb upward, the temperature drops significantly. So, if a mountain is tall enough, you get freezing, icy conditions sitting right in the middle of a hot tropical latitude. The second major modifier is how close you are to the sea. Oceans act like massive thermal batteries. Water takes a long time to heat up and a long time to cool down, which keeps the climate of nearby coastal lands very mild. Deep inland, it's a different story. Dry land heats up incredibly fast under the sun and loses that heat just as quickly at night, causing severe swings between scorching summers and freezing winters. Latitude sets the broad baseline for climate, but local geography, like towering mountain peaks and vast oceans, fine-tunes the exact daily weather a specific region experiences. For thousands of years, before modern engineering existed, human beings had to adapt their entire way of life to the specific rules of whatever climate belt they lived in. In the equatorial zone, the constant heat and rainfall meant that communities could settle in one place and farm tropical crops like bananas. In the desert zones, however, the total lack of water forced people to live as nomads, moving to wherever they could find water and pasture. And up in the polar zones, staying alive meant relying on heavy animal furs and highly insulated shelters just to keep from freezing. For most of history, your climate zone determined what you ate, what you wore, and the materials you used to build your home. But today, human engineering allows us to step outside those natural boundaries. Using massive piping networks and advanced mechanical irrigation, farmers pump enough water to sustain lush crops right in the middle of a dry desert. And we build huge glass structures that trap sunlight and heat, allowing us to grow warm weather plants even while snow falls during a freezing winter. We even modify the weather inside our own homes, using modern air conditioning to create artificial temperate zones during extreme summer heat. The sun and the geometry of the Earth will always dictate the major climate zones of our planet. But human ingenuity and technology have made us the only species capable of building a thriving life in every single one of them.